Morning to you, Math 8. Thanks for joining me for yet another episode of SBAC Prep. This is part 3. I know that I forgot to give some of you guys the guided notes for this practice, so if you want to take advantage of the extra credit and review, just to verify that you've watched the video, take out a separate sheet of paper and take some notes on numbers 12 through 18 that I'm about to show you. Write down the most important things that you think would be necessary for you to get the right answer, and definitely make sure that you ask questions on Monday if you have any. So thanks for tuning in, and let's get started. All right, so problem number 12 here tells us that a rectangle ABCD is rotated 90 degrees clockwise about the origin and then translated 3 units left and 2 units down to form a brand new rectangle. It asks us what the length in units of line segment AB would be in the resulting figure. Now, before you start freaking out and say, oh no, Mr. Ooey, I don't remember the rules for rotation, keep in mind about what I told you in terms of remembering to answer what they're trying to ask in the question. So I'm boxing up what they're trying to ask you here. They're just asking for one piece of information, and it's the line segment of the brand new figure that matches up to AB. So one thing that you should remember about what we covered for this unit is that whether we reflect or rotate or just slide an object around, we're not changing its size or shape. So if I look at my original rectangle, the original AB is nothing more, nothing less than just 5 units. And sorry for my handwriting. I do not have my stylus. I left it at school, so bear with me. That 5-unit length is not going to change no matter how I translate it around the map here. So keep in mind that before you start moving that around and drawing a brand new rectangle, answer the question. So big piece of advice here, answer the question and read your way through the question first and answer what it's trying to ask. So there you go, number 12 done. Bada bing. All right, so number 13 here states that Stephen claims that when you multiply two numbers with the same base, the new exponent is the product of the original exponents. And it shows us a little example of his work. Now what we need to do is we need to prove Stephen wrong. So here is our strategy for anything where we're finding a mistake or we're trying to sort of poke a hole in someone's argument here. Now what you should remember for sure is that when we multiply two exponents, we don't multiply the exponents here. We add them together. So even though he gets the correct result here, he doesn't do it by using the correct mathematics. So what we need to do on the right-hand side over here is we need to figure out an example that can prove him wrong. So honestly, there's a ton of different answers that you can choose here, but choose any two numbers for the first two boxes. So you're going to drag over those numbers on the right and say I choose 1 and 2 here in the boxes. Remember that when you multiply two things with the same base, you add the exponents. So if I have 3 to the first power and 3 to the second power, when I multiply them together, I just add that 1 and 2. I don't multiply, I add them, and I get 3 to the third power. So that example alone, just showing the correct steps here, are definitely enough information for you to get this right because it shows that his argument's wrong. So that's basically all you need to do. And you can choose any other two numbers using the correct mathematics here. So choose any of your own two numbers and you would definitely get this question correct. So there you go. Number 14 here is one of those intimidation problems. Looks like a bunch of information that they give you when in reality it boils down to a couple very straightforward math problems here. So it says David and Karen have a goal to read 10,000 pages together by the end of the summer. Good for you, David and Karen. It says David reads 80 pages per day. Karen reads 25% more pages every day than David reads. And it says that David and Karen agree that the model 180D is equal to 10,000 will tell them how many days it'll take them to read. Then they invite Rick to read to get their goal faster. Rick reads 35% fewer pages per day than Karen. It says which equation can be used to find how many days it would take Karen, David, and Rick to read 10,000 pages together by the end of the summer. Now, here's the first thing that I would do on this problem. Before you even start adding, subtracting, multiplying, dividing, anything here, I would use process of elimination to see if you can eliminate any of these answers because they don't make any sense. Now, David reads 80 pages per day, and Karen reads about 25% more than David reads. Adding another person onto that, they should definitely be able to read around a little more than 180 than David and Karen put together because they added that third person, Rick. To me, since Rick reads 35% fewer pages, this last one is a way too big answer. Now, the other ones are pretty close together, so I don't think that logically we can eliminate any other ones here, but at least we've eliminated one. So now let's see what we should do here. So what I know is David reads 80 pages, and Karen reads 25% more than David. So 25% of 80 would be 80 times 0.25, which would be 20, and that means that Karen reads 100 pages per day. So she reads 25% more than David. She reads 100 pages a day. Now I see where they got the 180. They just added the amount of pages that they read. Now, since Rick reads 35% fewer than Karen, since Karen reads 100 pages per day, 35% fewer than that, luckily 100 is an easy number to take a percentage of. I would subtract 35 from it, and that would give me a grand total of 65 pages that Rick is able to read. So in total, if I were to try and figure out how much they read altogether, it comes down to one very simple addition problem here. Adding those all together tell me that they read 245 pages a day, which would mean B is my correct answer here. Now again, this is one of those problems that seems very intimidating, but just boils down to really critically thinking your way through the problem and trying your best to use process of elimination. Number 15 here requires us to decipher a graph given the actual information on the graph. So this says the graph shows Parker's distance from home over time, and it gives us that nice, neat graph in time versus distance. So what we need to figure out is, based on this graph, determine whether each of these three statements below are true or false. So it looks like each of these statements require us to understand one basic piece of information is increasing, constant, and decreasing. Now the cool thing about this is that you can see in the graph that there are definite sections of increasing, constant, and decreasing. We just need to verify whether or not these statements are true based on these facts. So number 1 says Parker's distance from home is increasing between minute 1 and minute 4. So if you look at the graph, the section at the very beginning is definitely increasing. So this is a true statement. The second one says Parker's distance from home is constant between minute 6 and 7. So if we look for minute 6 and 7, it's right smack dab in the middle of the graph, which we can see is constant, so that is also true. The last one says Parker's distance from home is increasing between minute 12 and 14. If we look at our graph for minutes 12 and 14, it's at the very last part of that graph, and we see that it is actually decreasing, not increasing, which makes the last statement false. So bada bing, bada boom, we have answered number 15. Problem number 16 is something that I see a whole lot on the SBAC, and this is a systems of equations problem. Now we've done a bunch of work on systems. We've graphed them, we've solved them by elimination, we've done a lot of stuff with these guys. Now you're asking yourself, Mr. Uwe, it says, or you're saying to us that it's going to be a systems problem, but I don't see any systems. So here's the challenging part. The challenging part is that we have to read our way through the information and create our own system of equations. So let's read through our situation here. Mary is buying tickets for a movie. Cool. It says each adult ticket costs $9 and each child ticket costs $5. Mary spends $110 on tickets. Also, Mary buys a total of 14 tickets. What we're trying to figure out is how much each of the different types of tickets cost here. So let's do a little bit of analyzing here and see if we can come up with our system of equations. Now the first thing I'm going to do is I'm going to choose two different variables to represent adult and child tickets. So I'm going to use an A for adult tickets and a C for a child ticket. Now that I have these two variables set up, all I know for sure is that I can convince myself one equation for sure, and that is the money equation. Now, in total, how many she bought of each requires us to spend $110 total as depicted in the question. Now, what I know is that each adult ticket costs $9. That can be represented by 9 times A, plus a child ticket that costs $5. So what I have here is I've got one equation that tells me how much I spent. Now another equation that we can use is we can use this last piece of information that says Mary buys 14 total tickets. Using our same variables, which is the amount of adult tickets that we buy plus the amount of child tickets, I know that in total we would purchase 14. Now what you have is your system of equations. Now this is by no means the answer to your question, but what you need to remember and think back to is using elimination to solve for our systems here. So the one thing that I'm going to do is I'm going to try and eliminate one of my variables. So again, it doesn't matter which variable you choose to eliminate as long as you're choosing one to eliminate. So I'm going to multiply this bottom equation by -9. And the only reason why I'm doing that is so that I can eliminate the A values in my system. So once I do this, I distribute that -9 to every single term, and I get a brand new equation. So my brand new equation is -9A plus a -9C is equal to -9 times 14. So do a little bit of calculator here. I will get -126. Yep, that checks out. So this would be my brand new equation now that I'm using elimination here. So I'm going to erase all this portion in the middle because I've got my brand new equation. So now that I've rewritten my equation, this is where elimination can happen. So all I'm going to do is I'm going to combine these two equations. So top and bottom equations get combined. So what I wanted was the 9A and the -9A to cancel, so they cancel out. Bada bing, bada boom, works out. 5C minus 9C gives me a -4C. Cool. And last but not least, 110 minus 126 gives me a -16. Now the cool thing about this is the last step is to divide both sides by -4. And what I should find is the amount my child tickets cost. So I found one of my answers. My child ticket costs $4. Now, if I wanted to figure out what what the adult tickets cost, if you recall, I take this answer and I plug it back into one of the equations at the beginning. Now, it does not matter which equation you use. So you can use your old equation, A plus C equals 14, to also plug in this information. So if I plug C back into this equation in the middle here that I manipulated to eliminate, what I have is A plus 4 is equal to 14. Taking one last step, subtracting 4 from both sides, I see that my adult tickets cost $10. So this is a blast from the past in terms of elimination for systems of equations. The most difficult portion of this problem is probably going to be creating the systems yourself. So make sure that you take some notes here and consider how I got the two systems of equations. So problem number 17 requires us again to sort of poke a hole in someone's argument and sort of try and come to a conclusion about why their argument is wrong. So it says here that Marco says the interior angles of a triangle add up to 180 degrees, and he claims that the interior angles of a hexagon must add up to 360 because a hexagon has twice as many vertices as a triangle and can be divided into two triangles. Therefore, its interior angles must sum to blah, 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 blah. Now, realize that The biggest thing that you can do for yourself right here is just remember what a hexagon is. So a hexagon is a figure that has 6 different sides in it. So I'm going to try my best here to draw my hexagon that has 6 sides. So I've got 1, 2, 3, 4, 5, 6. Now, if Marco's argument is that the interior angles have to add up to 360 because there's 2 triangles, let's verify whether or not there's more than 2 triangles in here. So how we create triangles is we just connect 2 of these corners here. Look at that beautiful triangle. Another 2 of these corners, and I can already see that this hexagon is broken up into way more than just 2 triangles. So A says a hexagon does not have 6 vertices. A vertex is just a corner, so A is definitely not true. B says a hexagon can be divided into 4 triangles, not 2. That's definitely our potential answer here, so I'm going to mark it. C says the interior angles of a triangle do not add up to 180. That's a true statement, so that can't be why his argument's wrong. And last says Marco's statement is correct. Nah, bro, Marco's wrong. So definitely make sure that you're able to draw yourself a picture, especially when it's all about a pretty simple shape that you learn pretty early on. So definitely, again, this is another type of question in which you're poking a hole in someone's argument. So make sure that you're confident enough in your math skills to do a picture and to find the reason why his claim is incorrect. So there is number 17. Last problem in this section, believe it or not, is another systems of equations questions. And how I know this is it's trying to ask me to figure out 2 different values based on 2 different categories here. So what we can read is that Simone and Nang read a total of 23 books over the summer. Simone reads 5 more books than Nang. It says to enter the number of books Nang read. Now, if you think back to a couple problems ago, what you should remember is that we needed to first come up with 2 variables that represent our situation. So I'm going to pick an S and an N to represent the amount of books Nang and Simone read individually. So the first question, or the first equation that I can set up is this total number of books. So put together Simone and Nang, and I know that they read 23 books altogether. Next, I take the second sentence and it says Simone read 5 more books than Nang. So here is an expression that I can write. Whatever Simone read, I know that it was 5 more than what Nang read. So this right here is my system of equations. Now the cool thing about this is that this is a substitution problem. So notice that the second equation is already solved for S. So what I can do is I can take this entire piece and plug it in for S. So now once I do this, I get 5 plus N. Notice all I did was replace the S in the top equation with 5 plus N, plus that N is equal to 23. Now what I can do now is combine some terms. So I know that N plus N gives me 2N, so I get 5 plus 2N is equal to 23. And skipping a few steps here to solve for N, I subtract 5 from both sides and then I divide by 2. So 23 minus 5 gives me 18. So I get 2N is equal to 18. And my last step is to divide both sides by 2. So I get N is equal to 9. Now before you start plugging this back into one of your equations up top, realize that you have already answered the question, because all it's asking us for is the number of books Nang read. And since we know that N represents the number of books that Nang read, we've got our answer, which is 9. So this is another systems of equations problem. The hardest part, again, is trying to make sure that you're able to construct your 2 equations. Cool, so that brings us to the end of round 3 here. My advice for you is to keep on going and make sure that you keep your heads up and keep on gaining that confidence. Can you tell them to keep on going?
You want some banana?
She wants some banana. Okay. I gotta go get my daughter some breakfast here. So peace out. Thanks for joining me, and keep on going. Subscribe for more, and you should see more updates coming pretty shortly. So peace out and enjoy the rest of your day.